Section 8.1, we want to look at the surface area of a right prism. So what does that mean? The idea is that a box is essentially a rectangular prism and the idea of it being right basically just means that the sides are straight up and down. We can still work out the surface area for shapes that are slanted, but we're not going to worry about that for this class. So, turns out the surface area is relatively straightforward. We notice that the surface area of a prism with a polygon base and rectangular sides will be 2 times the area of the polygon plus the sum of the rectangular areas. And so we can do this with very complicated polygonal bases. We're going to be primarily concerned, once again, with regular polygons. For a base that is a regular polygon, we know that surface area is equal to 2 times area of the polygon plus n times so you have n sides of the polygon times the side length d times the height of the prism h, where d, we'll keep it all there, n is the number of sides, d is the length of each side, and h is the height of the prism. So if we go back to the idea of a hexagon base, a prism of height 10 centimeters with a regular hexagon base with side length of, let's make it 6 centimeters. We know that's going to have base area of 6 times 3 centimeters times 6 centimeters. Let's double check that. Yep. Which is going to be, whoops, we forgot about the 1/2. 6 times 1/2 times base times height. So that's going to give us 54 radical 3. Square centimeters. Which gives us approximately 93.5 square centimeters. So then we know that the total surface area is going to be 2 times, well, approximately 2 times that 93.5, plus we have 6 rectangular sides that are each going to be 10 centimeters tall by 6 centimeters wide. And so we're going to get 187 square centimeters plus 360 square centimeters, which is going to give us 547 square centimeters. And so we notice in general, we're always going to be looking at the area of the top plus the area of the bottom plus the area around the sides. So we actually generally call it the lateral surface area. So if we had some shape we think of that as surface area is going to be 2A plus lateral surface area, the area around the sides. So one thing we have to be a little bit careful of is we notice that geometry and trigonometry are very strict. If we tried to say that a pentagon, a regular pentagon, has side length 10, centimeters and area of 60 square centimeters. This is false. This is a false statement. It'd be convenient, but it wouldn't work. Because we notice that as soon as we say that's a regular pentagon and that it has side length 10 centimeters, we'd already seen that those angles have to be 36 degrees. And central angle had to be 108, and so the trigonometry tells us that the area is actually going to be 5 times 1/2 times 10 centimeters times the height is going to be 10 to the 36 times 5 centimeters. So that's going to turn out to be 5 times 5 times 5, so we get 125 times 10 to the 36 is 10 to the 36, we get 0.73. So that's approximately and so that's going to be times 125. And we get so you get approximately 91.25. Yeah. And so that guess of 60 square centimeters wasn't a bad guess, but obviously not terribly accurate. If that had been meters, if we had been trying to carpet that regular pentagon shape with 60 square centimeters of carpeting, it wouldn't have worked out at all well. And so this is why we need to make sure that we have accurate measurements. We can't just decide to make up measurements when we know how to calculate the correct measurements. And so this is a good case. If we had a right prism with regular pentagon base, with height 8 centimeters and side lengths of 10 centimeters. We know we already did the area of the pentagon, and that's really the hard part. We know that the total surface area is equal to 2 times the 91.25. So we should say approximately. We get 2 times the 91.25 square centimeters plus 5 times, we said it was 8 centimeters tall, times the side length is 10 centimeters. And so that lateral surface area will often be fairly straightforward. So we're going to get 182.5 square centimeters plus 400 square centimeters. And so we're going to get 582.5 square centimeters. So an easier one is just to have it out there is volume, surface area of a cylinder is the same kind of idea. We know that we need 2 times the base, area of the base, plus the lateral area, but conveniently we know that that's going to wind up being 2 times pi r squared. We know the area of a circle is pi r squared, and then we know the circumference of a circle. We're just going to get the height times 2 pi r, because we know the distance around the circle has to be 2 times pi times the radius, and so that's pretty straightforward. So a cylinder with height equal to 6 meters and radius equal to 2 meters has surface area equal to 2 times pi times 2 meters squared plus 6 meters times 2 pi times 2 meters. And so we end up getting 2 times 4 is 8 pi square meters plus 24 pi square meters gives us 32 pi square meters. And again, we notice that that's good for exact. We often don't have the luxury of ordering 32 pi square meters of carpeting, so we have to make an approximation, and we can say that's going to be approximately 100.5. That's approximately 100.5 square meters.